So let me get started with section 2.1, or 2.2 I should say, and working with some definitions of our trig functions. Now our trig functions are going to be defined, at least in this course initially, by functions of the unit circle. So as a reminder, the equation for the unit circle is x squared plus y squared equals 1. And this is what we're going to do. At some angle theta, theta is going to put you on a point, or theta is going to intersect your unit circle at some point. And the x-coordinate at that point is going to be the value of something called the cosine. And the y-coordinate at that point is going to be something called the sine. So cosine of theta, that's just going to be your x-coordinate. Sine of theta is going to be your y-coordinate. We're also going to define the ratio of these two as being your tangent. You know what? It might be in the other copier, the one way down there. Do you know the code to get in? It's all twos. Okay. Yeah, thank you. What is it? Yeah. So, just to write these out once, cosine is going to be abbreviated as COS. Sine is going to be abbreviated as SIN. And tangent is going to be abbreviated as TAN. So if you've ever looked at your calculator and wondered, what's cos, sin, and tan all about? Well, now you're actually going to learn. They're going to be either your points on the unit circle at a particular angle or the ratio of those 2 points. So the tangent is actually going to be the y-coordinate divided by the x-coordinate. So that's going to be effectively this distance here, distance from your point to the x-axis. Now we're also going to have the reciprocals of these functions. So 1 over the cosine is going to be the secant. I should probably start putting in some angles here, but I'm not just yet. 1 over the sine is going to be the cosecant. And this is probably the only time this semester that I'm actually going to write these things out. We're just going to go with the abbreviations. And finally, 1 divided by the tangent is going to be the cotangent. So yeah, a lot to consume all at once, but there it is. Now, the importance of knowing the unit circle and all the special values here is directly related to our approach to this trigonometry course. And that is, we're defining these functions as their points, their coordinates on the unit circle. Now that's going to mean sine and cosine are particularly well defined because as you go around the unit circle, your values of sine and cosine are strictly going to stretch between -1 and 1. So for the sine is your y-coordinate. The maximum that the sine could be is 1. The minimum is going to be -1. For the cosine can have a maximum of 1 and a minimum of -1. It's the x-coordinates. And they're beautifully well-defined functions. Now these other functions involve reciprocals or ratios. So like the tangent is your y-coordinate divided by the x-coordinate. Well, you can run into problems there if the x-coordinate is 0. Like at 90 degrees and at 270. Or with the cotangent, you can run into problems when the y-coordinate is 0. At 0 and 180. So these other functions are going to have problems. But the sine and the cosine, they're going to be in pretty good shape. So let's do a problem like you're going to see in your homework. And that would be find some trigonometric values of a particular point. So we'll start with this one right here. Square root of 3 over 2 and 1/2. Awesome, thank you. And let me kind of draw that. This is actually a point on your unit circle. Does anyone know what angle this happens at? Can you find that point on your unit circle? Where is that going to be? Yeah, it's at 30 degrees. So realistically, let me write it like this. So this is section 2.2. Let's find the sine of 30, the cosine of 30, the tangent of 30. We'll start with those. So the sine of 30 degrees, the cosine of 30 degrees, and the tangent of 30 degrees. What's that? Are we short one? Let me see here. 2.1, 2.1. Really? Okay. Just give that. So, sine of 30 degrees. Well, let's take a look at your unit circle. The y-coordinate there is going to be 1/2. So there you go, 1/2. The cosine, I need the x-coordinate. That's going to be square root of 3/2. And the tangent is going to be the ratio of these two. The tangent is going to be the y-coordinate divided by the x-coordinate. So it's going to be 1/2 divided by square root of 3/2. So let me write that. 1/2, let me write it out over here. 1/2 divided by square root of 3/2. That was kind of a mess. But let me remind you that when you're dividing ratios like this, it's the same thing as multiplying by the reciprocal. So that's going to be 1/2 times 2 over square root of 3. And now I can get rid of the 2's and get 1 over the square root of 3. Yay. So that's the basic 3. Now, there's some reciprocals of these. The reciprocal of the sine is the cosecant. Cosecant of 30 is going to be reciprocal of that, which is 2 over 1. Let's just write 2. The reciprocal of the cosine is the secant. So that's going to be 2 over the square root of 3. Now I know that we can rationalize that, and I'll turn my attention to that in a minute. And last but not least is the cotangent of 30 degrees. Cotangent of 30 degrees. It's going to be the reciprocal of the tangent. Now, you notice I didn't rationalize this yet. And it's my little trick that I always found it easier to take the reciprocal of this before I rationalize it. So that would be just the square root of 3. Yay. Now, if you wanted to rationalize this, and sometimes you'll need to, you're going to multiply by square root of 3 over square root of 3. You'll end up with 2 square roots of 3 over the square root of 9. But the square root of 9 is 3. So that's what it looks like rationalized. I'm not going to be really a stickler on that stuff. All right, rationalizing it's great. Theoretically, you should be able to do it, but I've got bigger concerns in this course than rationalizing. If you rationalize this one, you'll end up with square root of 3 over 3. Now we'll go back in just a minute and take a look at what that means, or what it looks like on your calculator. But for now, let's practice another one like that. You know, let me give you a more user-friendly one than one of these. And I'm going to let our point, P of x and y, have coordinates of, let's see, let's do 3/5 and 4/5. So x and y is going to have these coordinates. So P equals 3/5 and 4/5. Now, how do I even know that that's a point on the unit circle? So, is it on x squared plus y squared equals 1? Well, I hope so, because that's how we define our trigonometric values. So, let's see. If it is, I should be able to take 3/5 and square it, and add 4/5 squared and get 1. Let's see if that's true. That's going to be 9 over 25 plus 16 over 25. That's 25 over 25, and guess what? That is 1. So it works. That's actually a point on the unit circle. And let me draw it, roughly speaking. So 3/5 and 4/5, it's going to be someplace up here. 3/5 and 4/5. It's going to be taller than it is far out on the x-axis. You're going to be at some angle here, theta. But when we're with that angle theta, we can answer all our trigonometric questions. I can find the sine of theta, the cosine of theta, and the tangent of theta. And I like to write these, and then opposite I like to write the reciprocal functions. So the reciprocal of sine is the cosecant of theta, and the secant of theta, and the cotangent of theta. So we're working with this point over here. 3/5 and 4/5. Somebody at home, Sarah, what would be the sine of that point? Or the sine of that angle?
The 3 over 5 and the 4 over 5?
Yeah, so this is your angle. What would be the value of the sine? Which coordinate should I pick up for the sine? Do you remember?
Would it be I forgot the word of it, the C one?
So the sine is which coordinate? The x coordinate or the y coordinate?
Would it be the X?
So make me look good. Which coordinate is it? Yeah, the y coordinate. Thank you. Awesome. So 4/5. Awesome. How about the cosine? What's the cosine? Yeah, the cosine is going to be the x coordinate, so that would be your 3/5. And now the tangent is going to be the ratio of those two. So it's going to be the sine divided by the cosine. So 4/5 divided by 3/5. And let me give you a little trick here. Now you should be able to invert and multiply like we did in the last one. But when your denominators are the same here, they cancel. So, yay. So the tangent is going to be 4/3. Awesome. Now see if you can't rattle off these over here. What are those going to be? Some takers. 5/4.
5/3.
5/3.
3/4.
And 3/4. Beautiful. And you're done. Beanie, beady, beachy. Julius Caesar once came up to a battlefield and he said, beanie, beady, beachy, although it's actually pronounced more like a W, but it sounds better with a V sound. I came, I saw, I conquered. Well done. Yeah, got that one. So there's your Latin lesson for today. You're going to learn a lot of Greek here, so you might as well learn some Latin too. Awesome. Let's try some more here. If I get a chance, maybe I'll go back and do another one like this here, the one we just did. But let's see if we can do some of these things without a calculator and then go back and do some with a calculator. So doing some of these without a calculator is going to really mean understanding where these angles are. So for instance, the cosine of 7 pi. We're going to have to think carefully about that one. cosine of 7 pi. And let me write that one down. So the challenge for you is to figure out, well, where does that put me on my circle? Well, you should know that this is more than once around, right? In fact, let's see. Once around the unit circle in radians is what? How far? 2 pi. So what do I got to do to get 7 pi? It's going to be 2 pi plus 2 pi plus 2 pi. How many pi's do I have so far? So that's 3 times around the unit circle. What's left over? Yeah, 1 more pi. So this stuff we can kind of ignore. So equivalently, this is going to be the cosine of pi. Now, what angle is pi? Where does that put me on the unit circle? It's 180 degrees. So it puts you over here, going back to our unit circle. What's the cosine of pi? Nico?
-1.
Yeah, thank you. -1. Awesome. So cosine of pi and cosine of 7 pi, those are the same thing. That's going to be -1. Let's try and do a few more here without necessarily referring to our calculator. Not that there's anything wrong with referring to your calculator. And for the most part, I'm not really going to be taking away your calculator on an exam. But it's helpful to know these things. Let's take a look at... let's try 32. Sine of 30 degrees minus cosine of 45 degrees. Sine of 30 degrees minus cosine of 45 degrees. And let me write down another one. Let's do sine of 90 degrees plus tangent of 45 degrees. So the next one over, problem number 33. So we're getting 2 for the price of 1 right now. Sine of 90 plus tangent of 45. Okay, let's look at our unit circle for some of these things. Which coordinate do you associate with the sine? The x or the y coordinate? The y coordinate. Good. So the y coordinate at 30 degrees is 1/2. So this is 1/2 minus, and this is kind of funny. Which coordinate do you associate with the cosine, the x or the y? The x coordinate. But at 45 degrees, does it make a difference? No. You can screw that one up and you'd still be right. All right, but it is the x coordinate, so it is square root of 2 over 2. And that's it. You've got a common denominator, so you can do this. 1 minus the square root of 2 over 2. But that's it. That's as far as you go with that one. How about 33? 90 degrees. What's the sine of 90 degrees? Who haven't heard from in a while? James W? C. Thank you. What's the sine of 90 degrees? Yeah. The y coordinate there is a big 1. Now this one's kind of a fun one. The tangent. Tangent is the y coordinate divided by the x coordinate. But what's that going to mean when the y coordinate and the x coordinate are the same? What's a tangent of 45? They're going to cancel out, and what are you going to get? 1. Yeah, you're going to get a 1. So the tangent of 45 is going to be a 1. So this is really a very fancy way of saying 1 plus 1, and then you get 2, of course. All right. Let's do maybe 1 or 2 more of these, and then let me work with you on your calculators. Let's work down with some of these angles in... let's do problem number 38. The secant of 30 and the cotangent of 45. So secant of 30 times a cotangent of 45. All right, well, the secant is the reciprocal of which trigonometric function? Which one of our basic ones? Is it sine or cosine? Cosine. So it's a reciprocal of the cosine. And the cotangent is the reciprocal of the tangent. So it's 1 over the tangent of 45. As hard as you look for them, most calculators aren't going to have a secant and a cotangent button on them. Just not going to find it. All right? So you're going to have to work with the reciprocals here. Now the cosine of 30, well, it's going to be your x-coordinate there. One I heard from in a while. William, what's the cosine of 30 going to be, please? Perfect. Square root of 3 over 2. And the tangent of 45 we just did. That was a 1. Now when I divide by a fraction, I multiply by the reciprocals. This is just going to be the reciprocal of square root of 3 over 2, which is 2 over the square root of 3. And you can rationalize that if you want. I don't really care too much. If I care on a test, I'll say, rationalize. But for the most part, my inner child is going to be doing somersaults if you get at least this far. Okay. Let's take a look at these things on a calculator. Now, one of the things I like about the TI graphing calculators, the up-to-date ones, I think I saw an 83 in here. I mean, no offense, but it's a little retro. It's not going to show you this display at the top here, which is nice because this is telling me that I'm in radian mode. So if I wanted to calculate, for instance, the tangent of 45, if I did tangent of 45, I know I'm supposed to get 1, but I don't because it's in radian mode. So how do you change your modes? Well, you hit the mode key, and Nico, you can do this one as well. You hit the mode key, and you go down to radians. You come over here and press the enter key on degrees. Now I'm in degree mode, and you can see that here. Now if I did that calculation, let me clear this out here. Tangent of 45 should give me 1. Oh, and it does. Probably one of the biggest general mistakes that people make when they're doing their exam work is they have the wrong mode. And it's a bummer because I know, it's like, oh, I can see it, And as I said earlier, I try and be generous. I do give partial credit. I'm not going to take off a lot of points if you use the wrong mode, but you're still going to lose a little bit of credit. So try and be careful. It tells you the mode. For most of your calculators, it'll tell you the mode right up here. Let's do a couple other ones. What if I wanted to calculate the secant, or the secant of 30? Well, to do the secant of 30, I really got to take the reciprocal of the cosine. So to do that one, let's clear this out. I'll do 1 divided by the cosine of 30. Now your calculator is not going to give you a nice value with square roots like I got over here. But if you wanted to use your calculator to check yourself, you could, right? You could do it very easily. You can just say, oh, well, what's 2 divided by, I don't know, the square root of 3? Oh, they match. I think I got it right. So you can use your calculator to check yourself, and I strongly, strongly, strongly encourage that. Now, with all your values of the reciprocals, reciprocal of sine is cosecant, reciprocal of cosine is secant, reciprocal of tangent is cotangent. You're not going to be able to find those values directly off your calculator. You're going to have to hit the reciprocal key or do 1 divided by this like I did up here. I'll tell you right now that if I try to do the inverse here, you'll see this cosine negative 1. It has nothing to do with the reciprocal at all. Let me show you. Second cosine inverse of 30. Think I'm going to get 1.15? Nope. Calculator doesn't like that one at all. We got a long ways to go in this course before you get around to the point where you understand what that is. But just know right now that you can't use that to get the secant. It just doesn't work. All right. Let's do some in radians. So, for instance, let's start with problem number 48. It says, find the exact values of the 6 trigonometric functions of the given angle. Well, that given angle for us there is 5 pi over 6. So let's do that. So sine of 5 pi over 6, cosine of 5 pi over 6, and tangent of 5 pi over 6. Now across from these, I always like to line up their reciprocals because it's easy to go across like this. I'll do that for you on your test if I'm giving you blanks and I want things in specific places. So across from sine, what should I write? Cosecant. Well done. 5 pi over 6. Secant, 5 pi over 6. And finally, the cotangent of 5 pi over 6. Okay. Great. Let's take a look at our unit circle. What's the sine of 5 pi over 6 going to be? That's your 150-degree angle. What's the sine there?
1/2.
1/2. Thank you. 1/2. So a 1/2 here. And that makes it easy to get the cosecant. It's just going to be the reciprocal. That's going to be a 2. The cosine is going to be your x-coordinate, which is going to be square root of 3 over 2. Actually, it's going to be negative square root of 3 over 2 because we're in the second quadrant. When you take its reciprocal, it's still going to be negative. The reciprocal doesn't vanish just because you're taking the reciprocal, or the negative doesn't vanish because you're taking the reciprocal. So negative 2 square root of 3 over 3. And finally, the ratio of those two. So you're going to have 1 over 2 divided by negative root 3 over 2. The 2's are going to cancel. You're going to end up with negative 1 over the square root of 3. Now, before I rationalize it, let's just take the reciprocal. What's the cotangent going to be over here?
Negative square root of 3.
Excellent. Thank you. Negative square root of 3. If you rationalize it, you get negative square root of 3 over 3. It was easier to take the reciprocal before you rationalize it. Nice. Nice. Let's just confirm a couple of these on our calculator. Let's do, I don't know, how about if we do the cotangent? We should get negative square root of 3. To do that on our calculator, we're going to have to take 1 over what function? 1 over the tangent. Thank you. So 1 divided by the tangent. Uh-oh, we got a problem here, don't we? I'm in degree mode. If I did 1 over the tangent right now, 1 over the tangent of 5 pi over 6, I'm not going to get the right answer because I'm in degree mode. If I change that to radians, then I should be able to get the right answer. Right now, that doesn't look to me to be the square root of 3. Let's change the mode, change it back to radians. So cursor down, put your cursor over radians, press enter. And then I can exit out of here. Here's a cute trick for you. Have you seen this one before on your graphic calculator? If you hit the second button, then the enter key, it'll bring up your last calculation. Oh, that's nice. So I don't have to type it in again. And now, because I'm in radian modes, if I press that, I get negative of this. Huh. And that certainly looks to me to be like the square root of 3. And I can check that. Square root of 3, perfect. Nailed it. So you can check yourself on all of these. There's so much you can check that there's really very little that should be left to doubt when you hand in your exam. Okay, let's keep going. Some of these other ones, I don't know if they're going to make the cut for an exam question or not, but let's take a look here. let's try one that's a little bit more challenging, like negative 14 pi over 3. And understand that one. Now, it's sometimes tough to deal with radians. So let's try and understand negative 14 pi over 3 first, but maybe converting it to degrees. I'm just getting a good feel for what it's like in degrees, and then maybe playing with it in radians. So what's it going to be like? Well, let's convert this to degrees. If I wanted to get rid of units of pi and end up with degrees, I'm going to multiply by 180 degrees over pi. Effectively, I'm multiplying by 1. 3 cancels into 180 60 times. Units of pi will cancel out altogether. So that disappears and that disappears. So basically, it's 14 times 60. What is it? 840? All right. So this is going to be negative 840. Negative 840 degrees. Now that's more than once around the circle, right? And of course it's going backwards. It's a negative angle. So let's think here. How many times around the unit circle is that? Well, let's just work with 840. And if I subtract 360, I still know I'm going to have some more. So basically I can subtract 720 from that, and I'll end up with 120 degrees. So essentially, this is the same as a negative 120 degree angle. So this is equivalent to negative 120 degrees. Now you can solve this one in degrees or radians, doesn't really matter to me. But once we figured out where that's at, now we're in good shape. Before I start looking at the value of the trig functions at these angles, are we okay with how I got this conclusion of negative 120 degrees? You can do it working with radians. If you think of this as negative 12 pi over 3 plus negative 2 pi over 3. And that's really, well, 12 divided by 3 is 4. So it's really negative 4 pi. And that's twice around the circle in a negative direction, because 2 pi radians is once around the circle. So 4 pi radians would be twice around the circle. It just happens to be going in a negative direction. So it takes you to this angle, negative 2 pi over 3, either way you want to go. Now, negative 120 degrees is going to put you here at 240 degrees. And that's what we wanted. We wanted these coordinate points. So let's do this. Sine of negative 14 pi over 3. Cosine of negative 14 pi over 3. Tangent of negative 14 pi over 3. And then all the reciprocal functions. Cosecant of negative 14 pi over 3. Secant of negative 14 pi over 3. And finally, cotangent of negative 14 pi over 3. Now it's all going to go back to that point on the unit circle. So let me just write it up here for my convenience. Negative 1/2 and negative square root of 3 over 2. So there's your x and y coordinates at that point. If you're watching this later, pause the video for yourself. See if you can't fill in these values. But in the interest of time, let's just rock them out here. Sine is the y coordinate. So it's going to be negative square root of 3 over 2. Cosine is your x coordinate. Tangent is going to be the ratio of those two. Now something interesting is happening here with the tangent. What happens when you do the ratio of a negative number divided by a negative number? Positive. So even though both of these are negative, the tangent's actually positive. Square root of 3 here, and 1 over the square root of 3 here. Reciprocal of that one, that's just negative 2. Reciprocal of this one, you've seen this one before. That's going to be negative 2 over the square root of 3. And of course, that'll rationalize as negative 2 square root of 3 over 3 if you wanted to do that one. Nice. So it's all coming back to the unit circle. Unit circle, unit circle, unit circle. So if you want to do well in this course, it's helpful to know that one. Let's finish up with, let's see, 2 more. Now, I've said that we're always on the unit circle, and that's for the most part where we're going to be happy and comfortable. For a lot of these angles, you don't have to type them in. You don't have points for them on the unit circle, but you can still find their values. Like problem number 69 was the tangent of pi over 10. Let me clear this out. I'm in radians. I'm not going to look for an angle on my unit circle because I don't have a nice convenient one that matches that. But I can do tangent of pi over 10 divided by 10 and just get a nice decimal answer and round it. If I wanted the sine of 28 degrees, which was one of the other problems there, then what I'd have to do first is switch over to degrees. It should be a little bit less than 1/2 because tangent of, or sine of 30 was 1/2. So sine of 28 should be a little bit less than that. There you go, 0.47-ish. Nice. What if you're not on the unit circle? Problem set. Some of these points aren't actually on the unit circle. Well, there's a way around that you can use. If they're not on the unit circle, then you can divide by the radius of the angle, or the line from the origin to that point. So what do I mean by that? Let me show you here. Suppose you have some point x and y that maybe is in the 4th quadrant or something like that. Yeah, I shall draw one in the 1st quadrant. But it's not on the unit circle, x and y. Then x and y, here's your x distance, here's your y distance. X and y is going to lie some distance of r away from the origin. Now the way you calculate r is just the Pythagorean theorem. This is a right triangle. So r squared equals x squared plus y squared. And then sine, cosine, and tangent are all going to be defined again. It's just that now you have to deal with this r. So sine of theta is going to be y over r. Cosine of theta is going to be x over r. And the rest of them kind of follow from this. Tangent is going to be this one divided by this one. It's just going to be y divided by x. So tangent's not going to change. Neither is cotangent. Cotangent is going to be x over y. How about the cosecant? That's going to be r over y. And the secant is going to be r over x. So the nice thing about working with the unit circle is that the radius is 1. So if the radius is 1, hey, it's just sine is the y-coordinate, cosine is the x-coordinate. So there's a nice convenience to working with things if you're on the unit circle. And so my last example then is going to be, let's go to my problem set. Let's work with problem number 78. 5 and negative 12. So 5 and negative 12, that's our point. Let me draw that. Can anyone visualize what quadrant that's going to be in? Yeah, excellent. It's going to be in the fourth quadrant. So it's going to look like this. So I'll do a 5 here and a negative 12 here. And I'll have this point here. So my angle theta, if I do this as an angle in standard form, that's my angle theta. And this distance, I need to figure out what that is. Well, that's just going to be from the Pythagorean Theorem. It's going to be r squared equals 5 squared plus negative 12 squared. So it's going to be 25 plus 144 is 169. And if r squared is 169, r is going to be 13. Beautiful. And that's what I needed there. With this, I can fill in all my sines, cosines, and tangents, and more. Sine of theta is going to be the y-coordinate, which is this, divided by r. So it's going to be negative 12 over 13. Cosine of theta is going to be the x-coordinate divided by r. So it's going to be 5 over 13. And finally, the tangent of theta is going to be the y-coordinate divided by the x-coordinate, or excuse me, the sine of theta divided by the cosine of theta. Can anyone do that in their head? Do that cancellation for me? This one divided by this one. What nice thing happens when I divide things like that with those denominators? The 13 is going to cancel out, so it's going to leave me with negative 12 over 5. Now I'm hoping that the rest of these follow pretty easily once you got those first 3 done. First 3 are the hard ones. Try and fill in the last of these. This one's going to be the reciprocal. This is going to be negative 13 over 12. 13 over 5. And negative of 5 over 12. Yay! And that's it. That's it. Comments on that last one? So it's nice when you're working with things on the unit circle, because then you don't have to mess around with this r. It's 1 and all these nasty r's just disappear. But you can. You don't have to have things on the unit circle to work with the trig values of those basic functions. All right, good luck with this stuff.